This is NECO 2021 General Mathematics Paper 2, and we are answering question number 11A, and the question reads, find the inverse of a matrix A, where that matrix is a 2 by 2 square matrix with elements 6, 11 in the first row and 1 and 2 in the second row. Hence, solve the matrix equation AX equals to B, where matrix X has elements small letter x in the first row, small letter y in the second row, so it has 2 rows, 1 column. And matrix B is another matrix with 2 rows, 1 column, in which 29 is in the first row and 5 is in the second row. So let's attempt to answer this very question to get a solution to the problem, starting with the very first question that asks to find the inverse of this very matrix. The inverse of a matrix is given by the formula A inverse equals to 1 over det A multiplied by adj A, where det A refers to determinant of a matrix A and adj A refers to the adjoint of that very matrix A. So I'll now find what is det A, what is adj A. I will now substitute in this very formula to find the inverse. Starting with det A. Remember, A is a square matrix. It is 2 by 2 square matrix. To find its determinant, simply you now multiply the elements diagonal down, and you now subtract the products of the elements diagonal up. So determinant of this very matrix A is now going to be 60 multiplied by 2. That result to subtract from it the product of 1 and 11. 6 times 2 gives answer 12, and 1 times 11 gives answer 11. So subtracting 11 from 12 correctly give answer 1. So therefore, determinant of matrix A is now equals to 1. So you move to the next part, that is the adjoint of that very matrix. The adjoints of a 2 by 2 matrix, simply what you do is to interchange the element in the first row, first column, by the element in the second row, second column. You now interchange those two elements, and other elements you now negate them. So the adjoint of this very matrix will now have elements to 2 minus 11 in the first row, minus 1 and 6 in the second row. This is the adjoint of this very matrix A. So now go back to this very formula for finding inverse and substitute. You have determinant as 1 and you have the adjoint matrix as this matrix. So you now have A inverse equals to 1 over 1 multiplied by the adjoint matrix, which has 2 minus 11 as the elements in the first row, minus 1 and 6 as the element in the second row. 1 divided by 1 gives answer 1. So 1 times the elements inside this matrix, the elements remain the same. So you now have A inverse as a matrix with elements 2 minus 11 in the first row, minus 1 and 6 in the second row. This is the inverse of this very matrix, and that answered the very first part of the question. So move to the second part that asks you to solve this matrix. To solve this very equation, AX equals to B, what you simply do is substitute those matrices exactly. So you now have the matrix A, look at it here, and you have the matrix capital letter X, look at it here, and you have your matrix B given in the question, look at it here. The question says, hence, that means we have to use the result of our inverse to solve this very equation. So if that is the case, we now use the concept of inverse matrix multiplied by the matrix itself to get identity matrix. So A inverse multiplied by E will give identity matrix. So what I'm going to do next is to multiply both sides of this equation by E inverse, so that in the left hand side I'm going to have identity matrix. So multiplying both sides of this very equation by E inverse, you now have the inverse matrix first here, multiply by the matrix E, look at it here, then multiply by matrix capital letter X equals to the right hand side, the E inverse, look at it, multiplied by matrix B. So what I'm going to do next is to do the multiplication of the two matrices. By the left hand side, I'm going to multiply the E inverse and the matrix A. The concept says if you multiply inverse and the matrix itself, you have identity matrix. So this multiplication by the left will now give me this identity matrix 1, 0 as elements in the first row and 0, 1 as element in the second row. Even if you do the multiplication, this is what you are going to have. Then copy the matrix capital letter X equals to, then the multiplication by the right means the 2 times 29 to get 58 minus 11 times 5 to get minus 55. So 58 to minus 55 give answer 3. Then minus 1 times 29 is minus 29. 6 times 5 is 30. So minus 29 plus 30 gives answer this very one. So we continue. So now multiply this identity matrix by the matrix X. So 1 times X is X, 0 times Y is 0. So you have X here, and 0 times X is 0, 1 times Y is Y. So you now have a matrix with elements small letter X in the first row, small letter Y in the second row, equals to, I copied this very matrix. So you now have two matrices, and those two matrices are equal. Definitely the corresponding elements must also be equal. So X will now take a value 3 and Y will now take a value 1, and that answered the question very question. Let me just share with you quickly the mark distribution for this very question as it is there in the marking scheme. The very first mark is method 1 mark, and this method 1 mark, you have it when you now substituted correctly the determinant and the adjoint matrix in this formula for finding A inverse. If that is done correctly, you have this method 1 mark. And you now have the matrix for A inverse exactly as this matrix is 2n minus 11 in the first row, minus 1 and 6 in the second row. You have this accuracy 1 mark. Next mark is method 1 mark for substituting the matrices exactly in this equation AX equals to B. You have this method 1 mark. When you now multiply both sides of the equation by A inverse, you have this method 1 mark. And when you now perform the multiplication both by the left and the right hand side, you have this method 1 mark. And when you now have X as 3 and Y as 1 exactly, you have the accuracy 1 mark. So if everything is done correct in this question, you have 6 good marks.